Alright, so here we have an ice machine, not making ice super fast. You can see the low side, we're running 404A. Low side, run right around 0 right now. The ice is pretty thick on the plate, so that's probably about right. But look at this. It's 375 almost for the high side pressure. That's pretty high. I'm gonna go see what it looks like on the roof. Well, that doesn't look great. From them scooting it around. Line going up's really hot, line coming down is pretty hot. So I think we have a bad evaporator or condensing fan motor, because that's really high pressure. So if an ice machine like this is low, you might have a hot line here and a hot line here if there's a head pressure regulator. So if we look in here, I don't immediately see one. So I don't think this one has one. And I can feel the coil, and the entirety of this coil is hot, which means it is actually, the fan motor should be running, but it isn't. So I think we actually do have a bad fan motor. And possibly the fan motor is super hot. I'll have to pull off that cover and see. But don't be fooled if there's a head pressure regulator. A hot line here and a hot line here might not indicate an issue with the fan. It might indicate an issue with the charge. But in this case, the whole coil is super hot. So I'm pretty sure that it's an issue with the fan motor. So we'll check the voltage coming into the box here. 213 on the bottom. 213, so we're good with power going to the motor. So it really should be running this fan right now, because I don't think this one has a switch. I think it just sends the power from the contactor in the ice machine. So check this out. At some point somebody clearanced this so the blade would fit in here better by cutting that and bending it up. Interesting. But yeah, the motor is hot here, so ouch, very hot. So the motor has something wrong internally. I haven't heard it buzzing at all, so the thermal cutout might be open right now on the motor, but you can hear the bearing. It sounds pretty bad. So the thermal cutout, it finally opened up, and you can see how even when we give it a push, it doesn't take off. If it was just a bad capacitor, when you give this a push, the motor would probably take off. See how it doesn't want to? So it's either a bad bearing or bad winding. And when the power's off to it, it spins more freely. So it's kind of like electrically binding. So we will have to get a different fan motor for it. I can almost get it to go when I lift up on it. Interesting, it's like the bottom bearing has dropped down. But if I could hold up on it, it would maybe go. Yeah, it's shot though. I love whoever put this in before. They put a dab of silicone there to keep the water out, so this blade actually came off super easy. Really a good idea. So thank you to whoever did that. And then if you look at this, see how much slop? That's a lot of slop. So it is just a bearing that went bad in the motor. So once the magnetic field starts and tries to turn the armature, it just slams against one side and it can't turn, which is why it kind of turns freely like this, but it is just a bad end bearing. So I'm just gonna pull the motor out and take it back to the shop with me, make sure that we've got something that'll work with this frame, and then we'll come back and throw it in. So we'll be able to clean this really well. Since the fan is out, we can clean it opposite of airflow. Here's the old motor, here's the new motor, and it looks like they just have this little adapter bracket that makes it so we can use this style base, and that's gonna work really well. So I'm just gonna move this motor over to here. Another look at that very bad bearing. So I'm back and it is raining. Not like torrential or anything, but still a little bit wet. But we'll get her swapped out here. Shouldn't take us too long, I don't think. Just pull the blade out. and drop the motor in. Looks like it won't be a problem, but that shaft is still full length. So I just got to get it properly bolted. Just brought up my ratchet here and makes pretty fast work typically. Yeah, these things really are handy because they're a regular ratchet, but then when you want a little speed out of them, you just go, and then you can put it on and, you know, ratchet it the rest of the way. It's not an impact, so you have to still use it like a regular ratchet to break things loose, but just speeds it up threading nuts off of stuff. So I think that's going to be right for where that's at. Obviously we'll just hook up the black and the white wire, but this motor didn't have a capacitor mounted to it. You have to add it on separately. So I think I'm going to screw a little bracket here to hold the capacitor. Probably right here. There is a wire bracket down this corner. But most of the wires just kind of hang out in this compartment. It's not the most precise wiring setup. And obviously the white in this instance is not neutral, it's just L1 because this is a 230 volt, 208, 230 volt motor. Probably at this location it is actually running 208. Most of these old restaurants that I work at are 208. These wires are for if you wanted to change the rotation of the motor. You just swap the yellow for the orange so that they're crossed. But I think it's going to be spinning the right way, so we'll just have to switch it after the fact if it's not correct. I'll just have to turn on the ice machine now, and I gotta run grab set screw. I was thinking it was, I couldn't remember if it was the flat style or set screw. Whenever I try to save energy by not bringing my tool bag, I always make like a bunch of trips back and forth to the van because, I don't know, I forget stuff. Yeah, it's gonna be close. I don't know if we're gonna have to cut down the motor or not. Oh, it's really close. It's got like this much space. I think it's okay. I think we'll buzz these down and see what it looks like, but very, very close. I can feel heat rising out of it because it is trying to make ice now. So these lines are hot again. Yeah, it probably would be ideal to cut that shaft a little shorter, but it's not hitting, so I think we're gonna be okay. Just pull out my temporary lockout tool. Should start up. I gotta push the knife switch in. Now I need an insulated screwdriver. Stink. Let's see, maybe if I... Nope, I need an insulated screwdriver to push those. See the terminals? The little knife there and there. They're just barely moving. Another trip down to the tool bag. I'll just push it in with this Craftsman wrench. Okay. There we go. Yay! I think we are spinning the right way, but let's just make sure. Shut it off again. Yep, blades are cutting the right way and they're not hitting. I did actually almost forget to move these little plugs. These are installed in these little holes on the bottom of the motor. And you're supposed to move them to whichever side is facing up so that the motor can drain properly. See, I just pulled that out. Oops. There to go. Pulled that out from the bottom plug. and then move it to the top here. So don't forget about these. Supposedly, if you don't pull these out, the motor can like actually fill up with water. I've never seen that happen, but I've heard that it can. I don't know if you can see in there, but yeah, there's like plenty of clearance. So I don't think we're gonna have to trim that down at all. Should be totally fine. So in this case, it was actually the motor and not a head pressure regulator or low charge making those lines really hot. So just something to be aware of. I'll put in the description a link to another one of these ice machines that I worked on. And that one that I worked on had a low refrigerant charge, which was actually making it seem like it wasn't doing any cooling, and it was because of the head pressure regulator. So I'll just put that in the link below and you can check that out if you want to. Yeah, thankfully pretty simple. So hope that you enjoyed, and I'll talk to you later. Gotta go put away all my tools now and get out of the rain.